Hello and welcome to day 2. Today we're going to look at geometric sequences. We already know what they are as we went over it in class before, so just as a review, geometric sequences are exponential functions. And how do we get to the next term? But we multiply. So we can see right here, we've got the next equals now multiplied by our common ratio and our starting value right there. Or the explicit formula, which is the exponential function. We have our nth term, we have our first term, and we have our ratio. Notice that if you have an a1, we have to the n minus 1, or we have a to the 0 and it's just n. Most of the time we're going to use this top one here. So, let's get right into it. Find the common ratio, write a recursive, explicit, and then find the 24th term. So again, how do you go from 3 to 6, 6 to 12, 12 to 24, and 24 to 48? Well, hopefully you can all see that we multiply by 2. So what's the common ratio? 2. Now another way of finding this is you take whatever two terms you want, but they have to be successive terms, and you take them. So if we choose 12 and 6, 12 divided by 6 gives you 2. So that's another way of finding it. You can always take two successive terms and divide. Write a recursive formula. That's our next equals now. A sub n equals a sub n minus 1. That's our next equals now multiplied by 2, comma, a1 equals 3. The next one, explicit formula, is a sub n equals our first term 3 parentheses 2 to the n minus 1. And so to find our 24th term, we all know that we should always use the explicit formula. So a sub 24 equals 3 parentheses 2, n is 24 minus 1. So we're going to get 3 times 2 to the 23rd. It's going to be a huge number. And we know the 24th term, I'm going to cheat. And the 24th number is 25,165,821. Okay, so recursive, explicit, finding the 24th term. So let's describe the difference between arithmetic and geometric, but just as a real quick thing, we're going to common difference here. We add or subtract by a constant. For geometric, we're going to multiply by a constant. Now, why do I say multiply? Because remember, if I'm dividing by 2, it's still saying I'm multiplying by a half. So you are multiplying by a constant. Just like I should have said added, you should add by a constant, it can be negative. So for number 3, all I want you to do is these 3 bullets. You're going to state whether it's arithmetic or geometric, so look at the pattern. Find the recursive formula and find the explicit formula, so function notation for each of them. If it's a neither, you don't have to do it. Okay, so pause the video, try that, and then we'll come back and talk about it. And so, hopefully, this is what you got. Take a minute, pause it, look at it, and start anything and ask me questions next class. So moving on to the last 2 questions, most important questions I would say of this video. Let's look at number 4. Given a geometric sequence with terms a, the third term being 45 and the 9th term being 32,805, find the first term and then write a recursive definition for the sequence. Here's the most important thing that you need to know. To find r, you are going to take your whatever term, a sub n, divide it by a sub, we'll use another variable, q. You're going to take those 2 terms, divide them. If they were successive, just like I talked in the beginning of the video, then you could get r. But because they're not successive, in this case we have 3 and 9, we're going to do n minus q. So you're going to divide the 2 terms and then raise it where it says raise it to the n minus q, so those two terms subtracted. So let's look at what this would look like. We're going to say that r to the 9 minus 3 equals 32,805 divided by 45. This is really a sub 9 divided by a sub 3, so I'm going to raise it to the 9 minus 3. So I have r to the 6 equals 729. Use a calculator for that. How do I get rid of the r to the 6? Well, we've got to use what we learned before this year. Raise it to the 1/6. 729 raised to the 1/6 gives you 3. So all that work to get you the common ratio. Now, once you found the common ratio, we're going to use the equation a sub n equals a1r to the n minus 1. I know a sub n, let's use the easier one. Let's say it's 45. That's our third term, equals a1, we still don't know that. We do know our ratio, which is nice, times 3 raised to the n, our third, minus 1. So I'm going to get 45 equals a1, 3 to the second is 9. And then I can divide by 9 to give me a1 to equal 5. So now I have my ratio, I have my first term. So now we can do our recursive formula. So next equals now, so a sub n equals a sub n minus 1, multiplied by our common ratio 3, comma, starting at 5. And we're done with that question. Again, extremely important. How do you find the ratio? Based on given two terms, we divide the two terms and then raise the r to those what those two terms, what actual term it is being subtracted from each other. Very, very important. Moving on to the last one, same idea, given an arithmetic sequence with the third term being 45 and the ninth term being 32,805. Find a1 and write a recursive definition. So same idea, except now we know it's arithmetic. In this case, to find the rate at which it's changing, and it's a linear function because it's arithmetic, we're going to use slope. So all I'm going to do to find the common difference is take the two terms, subtract them, and divide by 9 minus 3. So I take the two terms, subtract them. It's just like x and y. X and y. Change in y over change in x. And that's going to give us 5,460. That is our common difference. Now we use the formula. A sub n equals a1 plus the difference multiplied by n minus 1. Again, use the nice term. Don't use 32,805 unless you want it to be difficult. So our third term is 45. We don't know our first term. We do know our common difference to be 5,460. And we do know what n is, 3, so 3 minus 1. 5,460 times 2 is 10,920. And then we're going to subtract that to both sides. And we are going to get a1 to equal negative 10,875. Big number. Actually, probably a really small number, negative. And so to write our recursive formula, next equals now, adding 5,460, comma, starting at negative 10,875. And that will do it for notes. Please make sure that you've highlighted or starred any questions that you have, and I will see you in class. Have a good day.